Hi, folks. We're going to take a look at page 403, number 9. So here, let's take a look at the question. So they say a sine is supported by a pole and a cable. So there's a sine, there's the pole, there's the cable. The cable is attached to the wall 2.2 meters above the base of the pole. So this is important here. So it says that the cable is attached to the wall. So there's where it's attached to the wall. And it's 2.2 meters above the base of the pole. So that would be the base of the pole. So that means that this side length is 2.2. Okay, so it's definitely something we would like to have in this diagram. And then it wants us to find the length of the pole and the length of the cable. All right, so let's go ahead and do that here. So first thing I notice is I don't have a right angle triangle. So hopefully at this point here, all we have is this new law called the sine law to help us out. So let's take a look at what the sine law gives us. Okay, it gives us a relationship between the ratios of side lengths and their opposite angles. Okay. Now, of course, this could also be written the other way around as sine A over little a equals sine B over little b. So let's see if we have enough information to solve the problem. So let's start with the pole here. So we look at the pole. So this is the first thing we're looking for. So I'll call that X. All right, and I have its opposite side, its opposite angle. So I know I'll be able to fill out one side of this equation. And the other piece of information I'm given, the only other length I'm given is this one here, but I'm not directly given its opposite angle. But because I have the other two angles, I know I can find it. So it looks like I will have enough information to solve this problem. So let's start by doing 180 minus 46 minus 74 to get that missing angle there. So this is 60 degrees. And so now I have enough information to solve this problem. Now, because my variable is a side length, that's why I'm going to use this version of the equation so that I've got my variable in the numerator. So let's start here. X is my side length divided by the sine of its opposite angle. So sine of 46 degrees is equal to the known side here, 2.2, divided by the sine of its opposite angle, which is sine of 60. And now I've got a nice, easy equation to solve because I just have to multiply both sides by sine 46 in order to isolate x. So what we have here is 2.2 times sine 46 over sine 60. And notice how I try to wait till the very end to find my approximation. So now we can find what x is, and what do they say, to the nearest tenth of a meter. So that's what we'll do. So here we've got 2.2 times sine of 46. Notice I do a little equal there just so I don't have to close off my bracket. Otherwise, I'd have to close that off. And then divided by sine 60. All right, and what do we have? Looks like we have 1.8. And there's the length of my pole. All right, so let's go to B here. And B asks us to find the length of the cable. And this is going to be a very similar problem because if I call this, say, y, okay, I can set up another equation. Y divided by the sine of its opposite angle, which is 74, is equal to. Now here I have two choices. I can use the same side opposite angle combination as before, or I can use this one here. But I'm going to choose to use the same one as before because 2.2 is an exact value. This 1.8 is an approximated value. So always better to use anything given that's exact. So I'm going to use the exact same ratio as I did before on the other side of the equation. So we have 2.2 divided by sine 60. And so y, again, I just multiply both sides now by sine 74. So 2.2 times sine 74 divided by sine of 60. And now we'll find our other value here. So let's do that. We've got 2.2 times sine of 74. So just to show you I can do it in one step, because this opens up a bracket, I have to close it. And now I can divide sine of 60. All right, so make sure you know how your calculator works. And here we have 2.4 meters. All right, so step number one here was to fill in the missing information that was not on the diagram, but that was given in the question. So make sure you identify it on the diagram. Step number two was to realize that because I didn't have a right angle triangle, I had to use some other method. In this case here, what we had was the sine law, and I checked that it did indeed apply. Okay, so in order to use a sine law, you need two combinations here, a side and its opposite angle and another side and its opposite angle, and only one of those can be an unknown, which is what I had here. However, I did have to do a little bit of work using the fact that the sum of the angles in a triangle was 180 to find the missing one that I needed, and then from there set up two equations, and we're done. That's it for this one.